All right, here's part 2 of my angles, inside, outside, or on for the vertex. And I have a picture of an angle where the vertex is outside. So again, if I had fancy technology, I'd move this angle in and I could see that I have an inscribed angle. So if I have an inscribed angle like this, whatever this angle is, let's say it's 50 degrees, then this arc is going to be twice that, 100 degrees. But if I take this vertex and I move it outside, this arc is now larger than twice, and I have an extra arc here that's being added in there. Twice the angle. I don't know what happened, sorry. If I subtract these two, then I'll get twice the angle. But it all boils down to, if I have a vertex that's outside, there are two intercepted arcs, and the measure of these two intercepted arcs, let me put this as x degrees, I need to subtract these and then divide by 2. So the measure of my angle x, where it has a vertex outside, is equal to the two arcs subtracted and then divided by 2. Now I have to subtract them in order. I have to do the larger arc minus the smaller arc. That's going to be arc AB, which is farthest away from the vertex, minus arc CD, which is closest to the vertex. If I subtract them in the opposite order, I'll get a negative value, and I don't want a negative value. And then I divide by 2. Okay? So just a quick recap of my different types of angles. If my angle meets on the inside for the vertex, but not the center, I call these secant angles because they're formed by secant lines. We don't always see the entire line. And I'm going to add the arcs, then I'm going to divide by 2. If I have secant angles where they meet on the outside, so here I have secants going as well, where the vertex is outside, also called secant angles, depends on where the vertex is. I'm going to subtract the arcs and divide by 2. So inside, I add and divide by 2. The vertex is outside, I subtract and divide by 2. So here is the formula that works. Just like the other one, I could always do 2 times the measure of angle x is equal to the arcs being subtracted. I suppose I should put my m for the measure. Okay, so I've got some examples here to work through with you. So here in this diagram, I have angles where the vertex is outside of the circle. So I have 2 intercepted arcs. So to find my angle, measure of angle x, is going to be equal to the 2 arcs subtracted, and I'm going to do the big one minus the small one, so that's going to be 55 minus 15, and then I divide by 2. Well, 55 minus 15 is 40, and if I divide that by 2, I get 20 degrees. So I don't have a cool way to add and subtract to get the same number, but the average of these two, if I add them together, no, sorry, if I subtract them and divide by 2, then I'll get that 20 to kind of double check it. For this second diagram, my vertex is still on the outside, and I've got these 2 arcs, but this time I know that the angle measure is 15. So I use the same equation, but my 15 is moved. So 15 is going to be equal to, and I've got to make sure that I put the one that I'm missing, which is the smaller one, is the one that's going to be subtracted. So I have 55 minus x, and then I divide by 2. It is not nice to divide something I don't know by 2, so I'm going to go ahead and multiply both sides by 2 so that I'm no longer dividing by 2. So 30 is going to be equal to 55 minus x. If I subtract 55 from both sides, I'm going to get a negative value, but that's going to be equal to my negative x. So negative 25 is equal to negative x. So when I divide by negative 1, my x value for my arc is 25 degrees. So I can kind of check this one out too. If I subtract these two, 55 minus 25, that's 30. If I half it, I get the 15. I've got some practice for you. It's uploaded and then it is due on Tuesday. I'll set a time due date for you all. Please let me know if you have questions. We can do a video conference. We can do a class conference. We can just send pictures back and forth to remind whatever works for you. But please let me know if you have questions.